again, let's continue to part 2 for this looping chapter. So within these parts, we separate in a few videos. The first one is we talk about this circle of cars. So let's start to do this together. So if you come to here, in the part 1, we know we can use these 4 with our open and close parentheses, and then you have this as a variable equal to the step. So this one is in the this syntax. You're starting from the first initial value, step, then the last value. And I can put those more variables. I put these numbers to count is what's the last value means, and thus use this step as the middle value times step and -1. So that is because you're starting from 0. And then you can have your model and you find a way to do this translate, or later on we will see the rotate. So any the transformation way that you can utilize the step to do this one by one. So that is the way to save your time to copy paste a lot of repeatable codes. So for the part 2, so we will do some the more complex things. In part 1, we only have either is a step in YXL or XXL. So let's do this diagonal row in 5. So that is in the between of X and Y. So let's save our car. So now that is part 2. First one, we will have this diagonal row. So how that will be? So let's consider. So what this means is we have our the step, and we need to translate both on X and on Y. So if we have numbers, now I change to 4. Looks like it's 0, 1, 2, 3, 4, though that is total 5. And then the step X, I put this 7. Oh, to our part is 8 is better. Step Y. Yeah, let's use this way. Is 50. Then what we can do is we can put this in the general I. So from 0 to what? So every time is we will have 1 and go to number cars -1. Oh, just the numbers of cars. So we will have 5 cars, so we go to 5, but we need to divide it by 1. And then translate is the thing. So we need to translate I times step X and I times step Y. So let's see what's happened. So what is the issue? So again, missing our semicolon. So let's see, this is same as here. So let's have a look is whether this can be fine-tuned. So if we use 1 and 1 and we don't need this -1, then that will be the case because your first is 1, then that's already make the step. So first is this thing. So if you have here I starting from 1, then here is better you start this is I minus 1. So that is the easier part. So you can adjust the part is the total number is 5, and then is when I use this number to do the looping as the end value, you need to use this number minus 1. So just remember this thing. And then they add a rotation transformation to the previous sample in order to turn the car around the Z. So every car we turn around the Z with 90 degree. So let's see. So this is 90, this 120, 80, and 270. So that means it's our rotate has also do some this stepping, but we need to rotate the car in this center first, then do the translate. So that's the translate for the rotate first, the translate second. So rotate should be inside the translate. Let's think about this. What are the rotate? So rotate x is 0, y is 0, but every time we should rotate the first car is 0, so I times 90. So second car is 90. So in this part direction. So let's see what's that will be happened. Let's have a look. What's the arrow? Ignore the rotate. So again, so rotate, RO. Then you can see we have this one. So just we have the 5 cars. So we use this so one code to finish this one. So let's look at the code. Rotate 0, 0, 9 times 90. So that's the same. And then we have another part. Let's save as. Second. So that is a circular. So not this diamond. It's not. So diagonal, so not the linear. We now have the circular. So how this will be doing? So we are using this sine and cosine, this formula. So now, if you see here R is we use this 200 times cosine. 200 times sine. This R is this radius for your car. How far they are far away to this center point. So now we will remove this. So we have is R equal to 200 for I equal 0. This 36 is a degree now, so we have this last degree before 360. So that means it's one total circle is 359. So we will have those as our the circular. Then if we just press F5, you can verify it's working. So no error first. Then we will have our car. So let's draw the car. So this car is in here, so nothing changed. Even we do this the road this 4 because we just draw 1, 2, 3, 4 is for 10 cars. So we need to do the translate. Translate is this point is based on the cosine and the sines this x and y. So translate r times cosine r times sine, then 0. Let's see. So now if I rotate here, you can see you have 10 cars. The first car is here because when is 0, the cosine 0 is 0. R cosine, cosine is the 1, and R sine 0 is 0. So y is 0, x is r. And if they come to the second one, it's the 36, and this is 72, and plus 36 for every car. And the last car is this one. So we have those the cars all together. So that is the circular. So you can see here using the sine and the cosine formula or function, you can do this the repeating. Not in the linear, not only in the linear. So that is the way. So if we want to see the number, so we let's put our number. So number is 10. So that is number of cars, and this is pattern radius. So we don't have this n used, and then we see the step. Step is 36 divided by n, so by number. So that is the step, and this is the 36 minus 1. And then we put this angle equal to I. Then we can see here, just to make that easier. So dx equal to angle times cosine I, dy equal to angle times sine I. So just remember that triangle with one are 90 degree the angle. So that is the formula that you can use, and now we can choose this is dx, this is dy, and with our car. So let's see. Oh, that is an interesting thing. So angle step dx dy car. So y is not like a circle, it's a start from this. It's interesting. Also, I didn't have this r times. So, but I create r. I think it's an interesting thing because that times dx is gradually the increase. But if we times r, not this. So that is not correct. Cosine angle, sine angle. I should not use the angle. Angle is the degree. So that I also use that as this step. So I put second. That should be sine. R times angle dx dy 0 translate. Let's see which has an issue. Oh, read error message angle. So sorry, I keep having some typo. So whenever you go to any typo, that will generate some strange things. So if you put this the change on the typing arrow, so now you can see here. So that's the grid part. So interesting. And here is the not only the 10. So 1, 2, 3, 4, 5, 6, 7, 8, 1. Oh, it's a 15. So let's make this 15. So what's that looks like? Yeah, you just keep adding those. If I put that 25, I think that's very density. So, and you start to have your PC running slower. So, but this number you can keep changing. So that's it for this circular. If you are not familiar with polar coordinates, play around with the following script. Try assign different value to the radius and the angle variable and see what the result position of the car. So car position. So let's play on this. Let me save this as the number 3. So car position. So we are not using this. We can use 200 still. Then we have the angle. Angle is 30. dx is radius times cosine angle. dy is r times sine angle. Let's say dz. Whether we have this r times, maybe we also have 10 angle. Then translate dx, dy, dz. Car. So you can see your car actually x translated is this cosine, y is sine, and they also have our height. This is the tangent. So it's from the x to y divided by x. So that's another triangle formula. But you can change here. So angle is 20, and you can see here. Then they are also moving. 20 to 60 is moving, and also get higher. So that is the ways you can now control your car's position using these polar coordinates. So play on that. I also add this Z XL, but you can keep changing yourself so that you can move your car to in this space, the 3-dimension space. So that is the parts, and we will have the more parts. So let's do some more exercise. So first is the parametric circular pattern of 14 cars. Let's save on this. 4. Let's have that. So remove this. So let's first examine this one. So we have 14 cars, but their head is all go to this the center. So first we need to have the circular, and then we also need to rotate our car. So what's the angle of rotate? Is actually this angle we defined to this to do this translate. So first let's do the radius. Let's use 200. So pattern radius. Then number is 14. So we did this. So don't forget about the semicolon. So number of cars. So that's the first thing, and the step is equal to 360 divided by number. And then we're starting to have our for loop with the open and close parentheses, and then you put your this looping parameter. So starting from 0, and you have your step. Step is 360 divided by number of car. Then last is 359. So you have closed this the brackets. Then we have our program file portion. So first is angle equal to I. So we have this one. Then dx is equal to r times cosine angle. Keep checking this the spelling, sign. And then what we will do is translate dx dy 0. So let's see car. So that's just the circular. So it should okay. We have angle. So r times the sine. So this one. And translate dx dy 0 car 19. Which one is let's read. Dx was assigned on line 39 but was overwritten. So that is my mistake. This should be the dy. And the dx dy r times the sine. So what we have that second. Ignore unknown radius r. So that should be radius. So we then have our car here, and we need to make the rotate. So let's add a second rotate. So rotate every time is we should rotate on the z is the 0 angle. Let's see whether that's multiple this one. So you can see here is it's exact the same as this angle rotate, because every the move you rotate the same the degree. So let's have our cursor rotate 0 angle. So that is perfect. So we have this one, and then another exercise is make appropriate change to the above script to create one pattern where all cars are facing away from the origin. Second is one pattern where all cars are oriented tangentially as if driving counterclockwise around the circular. 3 is one as if driving clockwise around the circle. It's like this. Circle is on the another the direction. So let's do this one by one. So first is let me save this. First we have this one already. Now we need to let their car face away. So let's see here. So number 5. So translate, you can see here how this back to the external. So that means here, if we say it's 30, for example, 30 degree, then it's need to, this is 0 degree. Now it's not show to the center. then is another is 100, 180. This is 30. So degree is should be from original one is head is go to the minus the x. We need to let them to rotate 180 plus 30. So that is angle minus 100, or we through this way. So let's just try to make this translate our work. So make that minus. Oh, just one sentence change. We have this one. So you can see here. So that's perfect. So that is one thing. And let's think about this way. So let's close this. So how make that is go follow the another one. So let me save on this one. So 6. We can play on that. Is if we see I want 120. So what's that? Is just have some way to see. So 150. Oh, on this direction. So that means is if I put this 110, 100, and 90. So you can see here. So 90 means exactly follow. So the follow for that is angle minus that is because here is the 0, then you go to the 90, and every time you add your step is add 90. So that is give you the this way. So let me save on this. And another thing is this one. So let's save on the number 7. Not counterclockwise, is clockwise. Let's see is if I use 90. Make that is not enough. So 200, 270 is also not. So that means is consider the first this one. From this to this, we just divide minus 100. So now we already have minus 90, then we minus another 100, then they will change to the another angle. So that total is 270. So that is on this angle. So in the sample, they just gave you the minus 270. So, but it's actually go with this 2-step. So if you look at this changing. So that for all for this part, we have changed some complex pattern for using these 14 cars. Next part is we will do our a little complex the wheel, and that will be added into our vehicle parts afterwards. Thank you for watching.